Welcome, Hornets, and thank you for joining me today. We're going to be taking a look at the basics of U-substitution for integration. I'm using the even problems from U-Substitution Worksheet number 1, which I hope will help you to understand what I'm working with. Now, please be aware, here is the first side of a two-sided worksheet where I will be doing the even problems. I recommend you take a moment to take a screenshot of the first side. Alrighty, please take a moment to take a screenshot of side number 2 so that you can see the even problems that I will be working on today in this video. Alrighty, let's go ahead and begin. Now, when you're looking at U-substitution, what I need you to remember is that U-substitution is working backward with the chain rule. That means that we have some f of g of x times some derivative of g of x that's sitting inside of this problem. See how this is the derivative of the chain rule? Let's call it f prime. That means that we're looking for some f of g of x that was our original problem. Now, if that's the case, then whatever is inside of something, see how we have a g of x inside and g prime of x is outside? There should be a decrease in power of 1 degree. See how this degree is a 2, whereas this degree is a 1. It is dropping by 1. That tells me that u is the 5x squared minus 3, and I'm now going to take my derivative du dx. I end up getting 10x, and I'm going to rewrite it as the differential, 10x dx. Now, if you wish, you can always jump from what u equals to du, and you can avoid this middle step. Please be aware, I will in general leave out that middle step and go directly to du. So just so you're aware, I don't want you to be confused. Now, I want you to notice we can rewrite this integral so that it is the 5x squared minus 3, the quantity cubed, times 10x dx. And now you'll notice that this right here is the du, and right here is u. By substituting directly, I get u cubed du, which I can now integrate by adding 1 to the power, dividing by the new power, and adding c. Instead of putting u in, however, I'm going to back substitute what I called u originally. Now remember, you can call it 1/4, 5x squared minus 3, the quantity to the 4th, plus c. Both of these are acceptable answers, and you simply have to decide which one you like best. Number 4. Notice the power is going from an x squared to an x. Therefore, u has to be 2x squared plus 3. The du is therefore 4x, the derivative of 2x squared. The 3 goes to a 0, and I add the dx at the end. I'm now looking at the integration of my u to the 4th power du. I now add 1, divide by the new power, and I have 1/5 of u to the 5th plus c, and I back substitute. And this is my answer. Once again, you can also write it as the fraction, so you could also write it as or 2x squared plus 3 to the 5th divided by 5, the quantity plus c. Both of these are acceptable answers, and just be aware we don't know what it'll be until we actively see the questions and the answers on a multiple choice test. Let's take a look at number 6, please. Number 6, I can see an x cubed and then an x squared, so the x cubed is u. 3x cubed minus 4 du is 9x squared dx. We're going to replace our u with what we called u and call it u to the 4th, and our du gets substituted directly as well. We now integrate and we get 1/5 of u to the 5th power. So I'm adding 1 and dividing by 5 plus c, and we put our 3x cubed minus 4 inside. Once again, you can rewrite it as a fraction if you choose. Number 8. 5x cubed minus 3, and we have a 15x squared. It's the x cubed to x squared. The u has to be the 5x cubed minus 3. du is then 15x squared dx. We substitute directly, and we get u to the 4th power times du to give us 1/5 u to the 5th. Once again, I'm adding 1, dividing by 5. Make sure it's to the 5th plus c, and put the 5x cubed minus 3. Now we have a fraction. Don't let that fraction give you a problem. All you need to do is notice that you have an 18x, it's to the 1st power, and a 3x to the 2nd. When we do this, we're going to let u equal 3x squared plus 1. That means that the du is 6x dx. We have too much. So what you want to do is you want to factor it so that you have 3 times 6x. We can now write pieces in as we need it. So I'm looking at the integration of 3 du, and I have u to the 3rd power. I'm going to rewrite this, pulling the 3 out from the top and writing this as u to the minus 3rd du. Make sure you can see it. I'm now going to integrate by adding 1. This gives me a negative 2, so I'm looking at 3 divided by negative 2. Now I'm going to put to the minus 2nd power plus c, and I'm back substituting. Now these types of problems, it's almost easier to not worry about that negative 2 exponent and rewrite it. Just leave it as you see it. It can, however, be written as negative 3 divided by 2 times 3x squared plus 1, the quantity squared, the quantity plus c. Turning the page, we're going to see more of that. Remember, we're going to have extra factors now. Here we go. Power of 3 to a power of 4. My 5 to a 4. So x to the 5th plus 3. du is going to be 5x to the 4th dx. And I have a factor of 4 that's too much. Pull the factor of 4 out. Put in your square root, which I'm going to call u to the 1/2, and replace your du. We can now add 1 to the new power, multiplying by the reciprocal. That's going to give me 8/3. We have u to the 3/2 power plus c, and we put in x to the 5th plus 3. This is my answer. Number 14. Power of 4, power of 3. U has to be 2x to the 4th minus 3. du is therefore 8x cubed dx. We have a factor of 3 too many. So it becomes 3 times the integration of u cubed du. We now add 1 to the power and divide by the new power to get 3/4 of u to the 4th power plus c, and back substitute the 2x to the 4th minus 3 for u. This is now my answer. Number 16. X cubed, x squared. I have a factor of 5 too much, so here we go. U equals 9x squared dx, and therefore, let's try that again. I just gave my du, everybody. Sorry about that. U is 3x cubed plus 5. du is then 9x squared dx. We pull out the common factor of 5. That's the factor that's not part of the 9x squared. I then have u to the minus 5th du, add 1 to the new power, 1 to the power, divide by the new power, minus 5/4. U is now to the negative fourth power plus C, and 3x cubed plus 5 goes inside. 18, we're almost done. X to the second, x to the first, let U equal 2x squared plus 1, so that the du is 4x dx. Notice that there is a negative that is not part of the 4x dx. So the negative comes out of the integral, and I now replace all of my pieces. Cosine of u du. Now when we integrate cosine, we go to sine. So I get negative sine of u, where I back substitute the 2x squared plus 1, and don't forget to add c. And this is now my answer to number 18. Our last problem. X to the fifth, x to the fourth, u is equal to x to the fifth plus 2, which means that du is 5x to the fourth dx, and therefore I can see I have an extra factor of 2. Take that extra factor out, replace so that you have secant squared u du, and now integrate to get tangent of u, where you back substitute x to the fifth plus 2, and don't forget to add plus c. And there is my answer. Alrighty, this constitutes the 10 even problems from the worksheet labeled as U-Substitution Practice Worksheet number 1. Alrighty, thank you very much, Hornets. I hope this has helped. Please remember to click like if you found it to be useful. If you have suggestions for me, please make sure you put those into the comments so that I can take a look and see how to improve. Thank you very much. Please be safe and take care, and have a fantastic day. Bye-bye, everybody.